Okay, so we are going to talk about the alcohol processes. So what is the question? How are primary alcohols prepared from prepared from carboxylic acid? Carboxylic acid. So this is a question in front of you. The question is what? How are primary alcohols prepared from the carboxylic acid? So how you solve it? See, we have to make a primary alcohols and it has to be carboxylic acid. As we draw the structure of carboxylic acid, it will be R C double bond OH. Okay, this is the structure of carboxylic acid that we know. Now we have to convert into the primary alcohol. So which reagent we should use? So the reagent we should use are, okay, let's draw the arrow first. Okay, and above arrow, the first reagent we use is going to lithium aluminum hydroxide, which is a reducing agent. So it will be lithium aluminum hydroxide. It has to be A and has to be proper. Aluminum hydroxide LiLH4. This is a second. We have to use a H plus or acidic medium. Okay, so what's going to happen in this case? Okay, let's change the ink so you will understand. See, this is a carboxylic group, correct? So what's going to happen here is this group is going to change because of the reducing agent, and it will become right now R CH2OH. OH. So what is happening in this case? How the primary alcohol prepared from the carboxylic acid? It will be, see, we know that this is a, see, this is the carboxylic acid, correct? This is the carboxylic acid that we know. Now this is your, you can say, primary alcohol, correct? This is your primary alcohol. So what is the change you are observing here? The change is very simple. See, I will show you. This is the carboxylic group, correct? This is because of the lithium aluminum hydroxide is going to change into the RCH2 group. So can we say in this reaction what happened exactly? The carboxylic group is going to change into the alkane, or we can say it got reduced as a CH2 group. So in this process, what happened? The primary alcohols are prepared by the reduction carboxylic acid. Carboxide is required strong reducing agent. Which is strong reducing agent? Lithium aluminum hydroxide is a strong reducing agent, and this is the process is actually occurring. Okay, so this is the actually the case. Okay, now let's study about exactly how the carboxylic acids are formed. Okay, so this is a generalized reaction. Let's talk about the little bit about the mechanism. Okay, so let's study about the mechanism. So when you talk about the mechanism, that simply means that however lithium aluminum hydroxide is an expensive reagent, therefore commercially acids are first transferred into the ester, which on catalytic hydrogenation give the primary alcohol. See, lithium aluminum is a costly one, and any industry will not prefer exactly directly use of that. So they do the alteration. What is the alteration is that they use the carboxylic acid along with ester. So let's study about that. This is your carboxylic acid, correct, which is going to react with R dash OH because they have to convert into the esters. This is very important point, and this is a equilibrium reaction which can be bring forward or backward. So here you will get your ester COO instead of H, R dash will be get attached along with generation of water molecule, that is H2O, correct. Now what the next process. See, this is an alteration to lithium aluminum hydroxide because that is little bit costly. So this is, we got the ester. I'm going to explain in detail, don't worry about it. This is your ester. Now this esters is going to react with hydrogenation reaction, that is hydrogen is supplied, that is hydrogen with the help of two reagent, that is nickel and palladium, nickel or palladium on vigorous heat, that is more important, and they will definitely form our CH2OH. So they also convert the carboxylic group into the CH2 along with regeneration of alcohol. So can I say alcohol is acting like a catalyst over here because it's undergo to form the ester C. We'll take here. This is the ester, correct? This is the ester which is formed here, and that ester is reacted with this hydrogenation over here, and which leads to the formation of this. So what exactly happened? Let's figure it out. See, in this case, this H got replaced by this R dash, which form the esters. Now this esters is going to react with the H2, that is hydrogen, when there is a nickel and palladiums are applied. Okay, so hydrogen is getting added to this, correct? So what is happening? Hydrogen is not getting added to this, it's added over here as well. So this group is become now CH2 group, and this OR group is changed to the RO dash group. This is the actually they form. Okay, so this is the reaction they occur. So this is how primary alcohol is prepared from the carboxylic acid. But for the alteration, they use this method from where the conversion of esters takes place, and those esters are converted into the alcohol. So this is the reaction actually they used.